Good morning and welcome back to the third section of Chapter 11. In this section, we're going to be looking at the shapes of data displays. We've seen a few pieces already, and in my statistics class, where we describe data a lot, I tell them that when we describe data, we need to cuss, which is an acronym. It's not what you're doing now when you're describing the data, but that means that we need to talk about the center, which is the mean and the median, the unusual points, which would be outliers. We've already talked about these things. The shape, which is what we'll talk about today, and then the spread, which would be the deviation, the mean absolute deviation, that MAD that we were looking at last time, and also the standard deviation that we'll be looking at next time. So right now, we are looking at this part of it. Some of this stuff is going to be seem kind of basic maybe. Some of it's going to be a little bit more advanced. So our learning targets today. I can interpret shapes of data displays representing different types of data distributions. So our shapes, we have two basic shapes. The first type is symmetric. In a symmetric distribution, we get the data that looks kind of like that. I know I didn't make a histogram there because we could have as many bars as we want. What we're looking at is it's big in the middle, and then it goes down on each side. That's a typical symmetric distribution. Really, all it needs to be symmetric is it needs to be the same on both sides of the middle. A uniform distribution, which just looks like that, looks like a big rectangle, is symmetric. This would be something we would get if we rolled dice a whole bunch of times and we measured how many 1s, 2s, 3s, 4s, 5s, and 6s we got. We should get about the same number of all of them, and that would be a uniform distribution. We could even have something really weird looking that was big on the edges and went down in the middle. That is technically a symmetric graph. We don't see those very often. The big shape that we get is going to be this one. It's going to be high in the middle, and then it goes down the further away from the center that we get. The other type of shape that we get is skewed. And when we have skewed data, it's going to have a tail on one side, or it's going to be heavier on the other side. So it's going to look kind of like that, or kind of like that, where we've got these tails over here where it gets stretched out. And again, these would also most likely be histograms. We could also look at them in box plots. In a symmetric box plot, the median is going to be in the center of the box, so that each of the boxes is about the same length, and then the whiskers are going to be about the same length as well. Not necessarily the same length as the box, but the same length as each other. And with symmetric, nothing is going to be fully, truly symmetric. It's going to be close. And that's what we're looking for. We're looking for close to symmetric, as opposed to obviously skewed. The box plots for these guys. So, this first one, we have the tail. These are the skewed graphs have names. And the tail tells us what the name is. The tail points the way. Here, in this one on the left, the tail is pointing to the right. So this is skewed right. And on the second one, the tail is pointing to the left. So it's skewed left. If we wanted a box plot for them, for skewed right, the median is going to be on this side of the box because it's being stretched to the right. And so this side of the box is going to be bigger, and that tail is going to be bigger, or that whisker. Skewed left is going to be the other way. We're going to have the median on the right side of the box because the left side is being pulled further. So we can see them with the box plots as well. So what do these distributions do? We can look at our measures of center here. We have means, and we have medians. Now, in a symmetric graph, they're going to be equal. And they're going to be equal at that peak. Now, is it fully, perfectly equal? No, because it's not perfectly symmetric. But if it was perfectly symmetric, yes, they would be equal. When we have the skewed graphs, what happens with the skewed graphs is these values are going in the tail are going to pull the mean a lot further than they pull the median. So the median in each of them is still going to be pretty close to the peak. It's going to be a little off to the side, but then the mean, if we actually calculate out the mean, it's going to be further. So I had a class set of test grades that had an average of a mean of 73.33%, and the median was 73.5%. I had a couple people not do it. When I included the zeros, 2 zeros, the mean moved from the 73.33 way down to a 66%. So it went from a mid C to a mid D with just the 2 zeros. It pulled it way down. The median went from a 73.5 to a 70.5 because it just moved one data point, basically, because it's the middle data point. So having those super small values changes it a little, but not all that much. So when we have skewed data, the mean gets pulled. The median doesn't get pulled all that much. The median is called resistant. It's resistant to outliers, while the mean is not. So what does that mean? Well, that means that we use a different center depending on the shape. When do we use each center? So if it is skewed, we're going to use the median. If it is symmetric, we could use either because they are the same or really close to it, but we use the mean because the mean is found using a formula, and so we can use it in different equations and things a lot better. There's stuff that goes along with that and the mean that allows us to use it more for more things. So if it's symmetric, we use the mean, but if it's skewed, we use the median because that's going to describe the center better than the mean will, because that mean just gets pulled off into the tail really easily by a few outliers. So this was the extent of the shape of our distributions. We have some problems on it. Practice. It's fairly easy stuff, but practice is still important. So keep working problems, keep asking questions, and as always, happy mathing.